Okay, hello and welcome everyone. So in this video, I'm going to do a series of exercises that have to do with price discrimination. So I'm going to talk about first degree price discrimination, second degree price discrimination, and third degree price discrimination. First, a warning, I just made a video for discussion for my 101 section and it didn't save. The audio did, but it wouldn't save the video. And so I've got to decide if I want to reshoot that video, although it's really difficult for me to get time where there's not going to be interruptions maybe from my puppy in the background. And so it might be easier for me to refilm the slides portion of that video, which means if that happens again, like I restart my computer, if this happens again, that's what I'm going to do with this one. So sort of a warning. Other thing is, before I begin, I'm going to show each of these exercises. So my students have these, but I might as well show each of the exercises and then go through it slowly. So that was the first one. Here's the solution I'm going to talk about, obviously. Here is the second one. Suppose a price discriminating firm faces these two demands. These two markets assume they have constant marginal cost. What price and quantity will the firm sell in each market? What price and quantity will the firm sell if it's unable to price discriminate? And then lastly, a second degree price discrimination problem. We have a couple different versions, different qualities, different costs associated with the qualities. Here's the table for the willingness to pay reservation prices for the consumers of two different types. Suppose they only sell one quality, what do they do? Suppose they only sell high quality, what do they do? Suppose both versions find the optimal price and profit. Okay, and you see my solution. All right, so if you stop the video, you can skip that part, but please watch. I don't know. All right, so the first one is a first degree price discrimination story. So suppose we have the following market. Inverse demand is prices equal to 420 minus 50Q. Assume all other firms in the market have constant marginal cost equal to average cost equals 20. This means the market demand is going to be given by this, and the costs is going to be given by a horizontal line, a line that's horizontal at a height of 20. I called this inverse demand because it is. This is the demand relationship that we typically graph with price as the dependent variable, quantity as the independent variable. If we solve this for quantity, that'd be the ordinary demand curve. Quantity is a function of price. Price is a function of quantity is inverse demand. It's the same information, and very often in intermediate micro, we're going to use actually the inverse demand version because we're typically going to be differentiating with respect to quantity. Although you can work with the relationship in the other direction, and there's certainly applications, namely elasticity, where you might be, and two-part tariff, where you might be working with demand rather than inverse demand. All right, so find the single price monopolies, profit maximizing price and quantity. So what the monopoly is going to do is they're going to produce the output where marginal revenue equals marginal cost, and then we go to the demand curve to find the price, and that's just how we solve it. Find the price and quantity if the market's perfectly competitive. Price equals marginal cost. Find the quantity. You should have the price for free because that's the marginal cost. And then find the price and quantity if it's served by a monopolist with first degree price discrimination. This is where we set the quantity of the competitive market, and then everybody gets their individual price. And then I'm going to ask for consumer surplus, producer surplus, deadweight loss. Okay, so here's the monopolies problem. I've set up the monopolies profit, 420 minus 50Q. This is P. And then here's Q. So P times Q, that's price times quantity. That's the revenue portion. This is the cost portion. Marginal cost times quantity. If we take the derivative, if I take d pi dq, this is now going to be MR equals MC, right? So I like to remind students to be able to go from the inverse demand to the marginal revenue. We'll take the exact same intercept, so 420, and then twice the slope to get marginal revenue, right? So go from 50 to 100. Why? Well, there's a derivative here of a q squared, right? So look what's going to happen. If I distribute first, it's going to be 420q minus 50q squared. And when I take that derivative, it's going to be 420, and then it's going to be bring down the 2, multiply by the 50, reduce the power by 1, there. And then here's the derivative over here. It's just this coefficient, it's 20. Then solving, move the 20 to the other side, move the 100q to the other side, divide through 4q. Okay, but this is the monopoly's quantity. Prices come from the demand curve, so I got to go back to the demand curve, and then my monopoly price is going to be 220. I'm going to show this on a graph in a second. So find the price and quantity if the market's perfectly competitive. This is just setting the inverse demand equal to the marginal cost. And then we find the competitive quantity and then the competitive price that was just marginal cost. Find the price and quantity if the market is served by the monopolist practicing first-degree price discrimination. Well, with first-degree price discrimination, everybody gets a personalized price. The idea, this is actually very information intensive. The firm would have to know what's the maximal amount each individual is going to pay, and then that's their price. It's really difficult to do, although with technology, this is becoming considerably more feasible. There's an interesting Freakonomics episode about Uber. So the Freakonomics author, Levitt, and Stephen Dubner, but Levitt was working with economists at Uber and then another team of economists on this paper. There's like 6 economists on the paper. And they were seeing how Uber was able to use their data in terms of the prices that people had seen and then either accepted or rejected whether or not you took an Uber, and therefore were able to back out and build a demand curve and presumably being able to estimate everybody's willingness to pay. And then what they're really after was determining consumer surplus in their market. So it's actually a super interesting podcast. Definitely should listen to it, especially because of this sort of real world application of economics. Anyway, so we know that the competitive market produces quantity of 8, which is going to be the first degree price discrimination quantity. Why? Well, you're going to set prices equal to everybody's individual price. So who are you going to sell to? Well, everybody who's got a willingness to pay above marginal cost. So the first person is going to be the person with a willingness to pay of like 420. Now, of course, it's going to be like 420 plus epsilon because 420 is the vertical intercept, and that's literally corresponding to where the quantity is 0. So, okay, right, fine. The first price isn't going to be 420, but for practical purposes, it is. Excuse me. The last price, it is going to be pretty close to 20 because you're going to sell all the way down to where the person's indifferent between buying and not buying. So I say set price equal to willingness to pay I for each consumer I. I'll show that on the graph. Calculate and compare consumer surplus, producer surplus, and deadweight loss across the 3 cases. Consumer surplus is the area under the demand curve and above the price across the units sold. Typically, it's going to be represented by the area of a triangle. So I have 1/2 base times height. So for the monopoly, it's going to be the triangle that's going to be above the monopoly price under the demand curve. So the vertical intercept was 420, the monopoly price was 220, and there's 4 units sold. So it's going to be 420 minus 220 times 4. That's a square or a rectangle, square. Multiply it by 1/2 gets us the triangle, 400. Producer surplus, this is going to be the price minus cost. So 220 minus 20 is 200 times 4 is 800. This is a rectangle or square. So producer surplus, this is like profits. Difference between producer surplus and profits is producer surplus is going to lack, typically going to lack fixed costs. But apart from that, we'll treat producer surplus just like profits. This is like the monopoly's profits. Deadweight loss, this is going to be the foregone economic activity. These are going to correspond to the units between where the monopoly is stopping and where the competitive market would have served. Right? So the monopoly produces 4 units. The competitive market would have produced 8 units. So there's 4 units that are not produced, and that's lost activity. That's lost gains from trade. That's deadweight loss. This is corresponding to the area of a triangle. It's going to have a vertical height of 220 minus 20, and then horizontal length of 4, and then it's going to be 400. For perfect competition, I'll show you the graph in a second. So perfect competition is going to be 1/2 height of the demand curve minus the price, cost. So it's going to be 400 times 8 is 3,200, divided by 2 is 1,600. There's no producer surplus and no deadweight loss with perfect competition. That's going to be the perfect competition. Competitive market maximizes total surplus. With first degree price discrimination, situation similar. It's just that what was consumer surplus with the competitive market is now producer surplus with first degree price discrimination because the firm is able to perfectly extract all the surplus. There's no consumer surplus and there's no deadweight loss. It's also efficient. So from the standpoint of like the metric of economic efficiency, economists wouldn't have that as a criticism of first degree price discrimination. It's not great for consumers, obviously, but it's not inefficient. All right, so here is the graph for the monopoly case. We said the monopoly is going to maximize profit by producing a quantity of 4 and a price of 220. All right, so that's this picture. Here's my inverse demand curve, my demand curve. Price on the vertical, quantity on the horizontal. Here's my marginal revenue curve. It's got the same vertical intercept, but twice the slope as the demand curve. Matter of fact, it's going to cross. Here's where marginal revenue is 0, but marginal revenue equal to 0 is the condition for maximizing total revenue. So this is going to be the revenue maximizing quantity. This is also going to be the midpoint of the demand curve, right? 8.4 divided by 2 is 4.2. So this is the midpoint of the demand curve. This is also where demand is unit elastic. Right? Anyway, but that's not where the monopoly is producing. The monopoly is going to produce where marginal revenue crosses marginal cost. That's this quantity of 4. Go up to the demand curve to get the price. It was 220. Consumer surplus is going to be these two segments, right? The area under the demand curve and above the price. Deadweight loss is right here, and producer surplus is right here. Deadweight loss corresponds to the units that the competitive market would have produced, but the monopoly doesn't. And it's bad because the demand curve lies higher than the cost curve, meaning that consumers would value those units more highly than they cost to produce. All right, and that's this picture here. I'm going to make my graph a little bit smaller so you can see. This is exactly what I just described. This is the monopoly situation: consumer, producer surplus, and deadweight loss. Here's the competitive situation, right? Consumer surplus is the whole area under the curve. And then first degree price discrimination, it's pretty much the same. What's the difference? Well, now the marginal revenue curve is the demand curve. Isn't that weird? It's got to be though, right? What's marginal revenue? It's how my revenue is changing when I sell another unit. What's happening when I'm selling another unit? It's corresponding to exactly the maximal willingness to pay of consumers, which traces down the demand curve. Okay. So demand equals marginal revenue for first degree price discrimination. All right, and that's just this right here. All right, number 2. Suppose a price discriminating firm faces market Q1 equals 36 minus P1 in market 1, and Q2 minus 36 P2 in market 2. Assume the monopolist has constant marginal cost equal to 12. What price and quantity will the firm set in each market? Well, this is a third degree price discrimination story. This is where the firm is free to set a different price in each market. What the firm's going to do, though, is we can actually treat this as a separate monopoly profit maximization problem solved twice. So in market 1, I'm going to find MR equals MC. And in market 2, I'm going to find MR equals MC. And this is going to give me my monopoly quantity in market 1, my monopoly quantity in market 2, and on the respective prices. Right? So if this is my inverse demand, marginal revenue has the same intercept, so 36, 36, and twice the slope. Uh-oh. That's not good. I didn't do twice the slope, did I? No, I did not. And I need to fix this. I need to fix this right now, because I've done so much in this video already that I don't want to have to redo this. All right, so I need twice the slope. So twice the slope is going to give me a 2Q here. Okay, good. Move this 36 to the other side. That's still going to be 24. Move this 2 to the other side. That's going to be 2. It's going to be an arrow. Good. It's going to be a 2. Oh, let's see. There we go. I copied it. All right. So let me double check that I just lost that 2 there originally. Let's see. So inverse demand was 36 minus Q1. Marginal revenue is therefore got the same vertical intercept, twice the slope. Okay. Let me check my math. I'm going to move this to the other side. That's going to be a 2Q1. Move this to the other side. 36 minus 12 is 24. Yep, that's right. 24 divided by 2 is 12. Yeah, good. Okay, so that looks much better. No, it doesn't. It looks horrible, but at least it's not wrong. All right, so market 2. What's going to happen here? We've got the same vertical intercept, twice the slope, going from the inverse demand to the marginal revenue. So going from 18, 18 is still my vertical intercept. My slope goes from 1/2 to 1. All right, and then solving 6 to one side. Okay, so my monopoly quantity is 6, my monopoly price 15, right? Monopoly price is 15 because that's going to be 18 minus 1/3 times 6. Or sorry, 18 minus 1/2 times 6. All right, so that part's right. So this is going to be the quantity I sell in each market. One thing I want to call your attention to is sum up the quantities. So sum up the quantities. So we have, oh, I'm an idiot. So this was this was my quantity. So this was, this is actually still wrong. This has to be a 12. I like that arrow. That's good. Real good. Good video, Ben. Good video. All right, so Q1. Text box. So Q1 is going to be equal to 12. And P1, well, let's see. So price is going to be 24. Actually, I had this backwards then. Let's cross through that. So now I wonder how many people caught when I was proclaiming, so brashly and boldly proclaiming that I hadn't made a mistake. Or they'd only make a typological mistake. And it's like, at least it's not wrong. It was really wrong, wasn't it? I wonder how many people caught that. Comment if you did. I guess kudos. So this is 24. Good. All right. So I've got my two markets. I want to add up my quantities now. So my total quantity between the two markets is 18. I'm going to sell it at a price of 24 in market 1 and a price of 15 in market 2. All right. So then this was good. I don't know. I didn't look at this, which is bizarre because I typed this out like moments before I wrote it out. So. Good. All right. So what price and quantity will the firm set if it's unable to price discriminate? Well, if they're not able to price discriminate, they got to treat the two segments of the market as a single segment. So treat the two market segments as a single one. So I'm going to add up the two demands. So we had 36 minus P1 in one market, 36 minus 2P2 in the other market. So we have 72 minus 3P. Solving to get my inverse demand, it's going to be 24 minus 1/3 Q. My marginal revenue has the same vertical intercept, twice the slope. So it's going to be 24 minus 2/3 Q is equal to 12, or 12 is equal to 2/3 Q. 3 times 12 is 36, divided by 2 is 18. What's the associated price? 24 minus 1/3 of 18 is 24 minus 6, which is 18. All right. So notice my monopoly quantity in market 1, my monopoly quantity in market 2 sums up to 18. Notice this price right here, 18. It's higher than this one. It's lower than this one. So what's happening here? Because we have a linear demand curve with third degree price discrimination, we're ultimately going to sell the same quantity whether we use price discrimination or not. However, we're going to sell at a different price in the two markets. What's going to happen is the demand that is more inelastic is going to have to pay a higher price. The demand that's more elastic is going to get a discount. So what's going to happen is my more elastic, my more responsive demand, my flatter demand, think this is going to be a flatter inverse demand curve, right? Slope of 1/2 is flatter than a slope of 1. So market 2 is going to get a discount, certainly, right? 15 is less than 18. And market 1, with a more vertical demand curve, is going to pay a higher price, 24. That's exactly what happens. We expect with third degree price discrimination, we typically expect the market with the more elastic demand is going to get a discount, in some sense subsidized by the market that has more inelastic demand. And with linear demand, the summing up the quantities sold in the two segments has to equal the sum or the total in the market. If it has to equal the total you get if you pool the demands and don't price discriminate. And that's true only of linear demand, or true of linear demand. And then if we don't have linear demand, it may not be true. All right, so the second degree price discrimination question. A firm has the option to produce different versions of their product or service, high or low quality. The marginal cost to produce low quality is 20. Marginal cost to produce high quality is 35. There's two types of consumers, A and B, with 100 consumers of each type. These consumers have the following willingness to pay. Type A will pay $35 for low quality, $50 for high quality. Type B will pay $45 for low quality, $80 for high quality. You think of this as like software or something like that, right? So think of like Adobe, or think like Photoshop, or think of like even Microsoft, or think of some type of software is a really good example where there's like the usual user group, like education or home users, and then there's the commercial grade. So if you're using Adobe, like Photoshop, and you're just doing this for like home use or something, it's very different than like for professional photography. Or if you're thinking about the version of like video editing and you just have like iMovie or Final Cut or whatever, that's different than the version you'd have for like professional, for a professional job. So the idea is we have low or high quality. It's a version of one product. All right, so suppose the firm decides to sell only the low quality. What's going to be the price? Well, if we're only going to sell the low quality, it'd be a price of 35. Then that's equal to the willingness to pay of the type A group for the low quality. My profits are going to be 35 minus 20 times 200, because I have 200 total people buying, for profits of 3,000. We could check, what if I wanted to only sell the type B consumers? Could do that. You could. So then my per unit profits would be 25 times only 100 would be 2,500, right? Because now I'm only selling to 100 because the 45 is too high for my type A consumers to buy. With second degree price discrimination, there's two problems. One is if you set the price too high for the low quality, you'll lose your low quality, you lose your low willingness to pay consumers. If you set the price too high for high quality, your high willingness to pay consumers will just buy low quality. So we always want to avoid that, and that's going to be relevant for Part C especially. Suppose the firm only offers a high quality, check the optimal price and profit. Well, here we want to set willingness to pay, price equal to willingness to pay of our type B consumers up to 80, and only sell to 100 of them. So 80 minus 35 times 100 gives me my 4,500 in profits. We have to at least check, what if I wanted to set my high quality, my price of the high quality good low enough that both groups buy? So now it'd be 50 minus 35 times 200, because both groups are buying. That's 3,000. Nope, I'd rather just sell at the high price to my type B consumers and ignore my type A consumers. All right, so suppose both versions are offered. Find the optimal price and profit. This is the one you're going to have questions. So what do I want to do? And in general, when I'm selling both versions, I'm going to set the price for the low quality good equal to my willingness to pay of my lower demanders, equal to 35. And I'm going to set the price of my high quality item equal to the willingness to pay of my high demanders for high quality minus the consumer surplus they'd get buying the low quality at that price. So this means I'm going to set a price of 35 for the low quality and a price of 70 for the high quality, or 69 or 70 minus epsilon. And your question is going to be, why not 80? Why not 80? It's pretty obvious why I want to set the low quality price equal to 35. Here's what's going on. With second degree price discrimination, we have our consumers facing a menu of options. All the consumers are going to see all the prices we offer, and they're going to choose which is right for them. So our type A consumers are going to see both prices of low and high quality goods, and we want them to buy the low quality good. I mean, we would like them to buy the high quality good, but it turns out if we offer a price that'll entice them to do that, we lose money. So we're going to set the price, we're going to intend for the type A consumer to buy the low quality good at a price of 35. That's the most we'll be able to get from them. Then we're going to set the price of the high quality good at 70. Because if we set the price of the high quality good higher than 70, our consumers at type B are just going to buy low quality. Because what's my consumer surplus for my consumers at type B at the price of 35 for buying low quality? 45 minus 35, it's 10. So that's why I can't charge any more than 10 less than this for the high quality good. Here's the work down here. Why? So here's the profit, 70 minus 35 times 100, 3,500 obviously. 35 minus 20 times 100 is 1,500. So profits are 5,000. Note that's higher than our profits in the other two cases. This is profit maximizing, so that's good. Why not set the price of the high quality good equal to 80? Well, then look at my consumer surplus from my type B consumer buying at a price of 80. It's 0. What's their consumer surplus if they buy the low quality good at a price of 35? It's 10. So the type B consumer will buy low quality if the high quality is too expensive. So that's why the price has to be 70 and not 80. Okay. Well, I hope you liked the video. Hope you liked it more than I did. So anyway, have a good night. Stay healthy. Stay safe, everyone. And I will see you next time.